Breaking news! Sir Isaac Newton stated, an object at rest stays at rest unless acts upon by force. An object in motion will stay at the same direction and same speed as acts upon by force. This basically means that an object at rest will not move unless a push or pull acts upon it. Now let's go to Tommy, who's soaking up in Florida, to tell us what static friction is about.
Thanks, Nazla. Well, static friction is the starting push or pull of an object, also known as the hardest part of starting your ride. I'm trying to get my car started, but it's not working out too well. Well, Nazla, back to you.
Thank you, Tom, for a very detailed explanation of static friction. However, we're not done yet. We still have 2 more frictions to talk about. Now let's go join Antonio in the frigid mountains of Antarctica to tell us what sliding friction is.
Hey, now I'm trying to do my car is stuck.
Anthony, what you just experienced was a sliding friction?
Yes, Nazla, you were right. When I started to turn on my car, it made
Yes, because the floors of the wheel sliding against each other made a bond, that which is broken.
I still have a long way to get to the station. I better be going back.
We have covered all the frictions except one. The last one is rolling friction. Monica will explain to us what that is. No. Hello there, Monica.
What's up, sister?
I'm wondering if you could explain to us what rolling friction is.
Of course I will, no worries. So as you can see, rolling friction occurs between the wheels and the ground. Eventually I'll come to a stop if I don't keep on twisting the wheel to make the car move. Rolling friction between the wheels and the ground is less than sliding friction between a book and the ground.
Of course, now we understand the rolling friction in a plasma car. However, let's have other news members explain to us what unbalanced and balanced forces are. As you can see, when Tommy and Anthony were fighting in the car, they were pulling it at the same force to which it became balanced. But when Monica came over and helped Tommy, the force became unbalanced, and then Monica and Tommy won the car. We had 3 laws. We went over the first one. Here's the second one. He stated, acceleration is a product of force and mass. Here are a few scenarios in which Newton's second law is shown.
If the mass is constant or unchanged, there is more force on an object, and as a result, the acceleration increases.
If the mass is constant and there is less force on the object as a result of acceleration and decrease.
If the mass is decreased and the force is unchanged or constant, as a result, the acceleration increases. So in other words, the less mass given, then the acceleration increases.
If the force is constant or unchanged, then the mass is increased, as a result, the acceleration decreases. In other words, the more mass given, the acceleration decreases. Go to Tommy for him to demonstrate what Newton's second law means.
Well, I have these cinder blocks here. They're kind of heavy, so my acceleration isn't all that fast right now.
Here, Tom, let me help you today.
At first, Tommy couldn't push the cinder blocks because it was too heavy. But when Anthony came in and helped him, it was much easier. Newton's second law generally affects acceleration of the cinder blocks. Tommy, I still have Newton's third law. Newton said, for every action, there's an equal and opposite reaction. Monica, can you please explain what Newton's third law means?
So as you see, Tommy demonstrated by hitting the wall.
Why did Tommy go backwards?
Tommy hitting the wall, and the wall reacted by pushing Tommy back from the wall. So the outcome was Tommy falling towards the floor.
Oh, okay, Monica, I get it. Well, that's all, folks. See you next time on